David Whitlock. We're going to be covering pair programming and test-driven development tonight, and so that should be fun. So I'll let you guys take it away.
It should be fun. Hey. We're here for a couple of hours, and Lisa invited us to talk to you guys about test-driven development and pair programming. And there are two of us, because it would be like ironic, but not like cool ironic, to just have one person up here talking about pair programming.
That's the thing you should do.
Yeah.
We're not going to show you how.
Just imagine there are two of us. No. And so despite that, Jason has a bum foot and everything, we're here, and we're really excited. So the way we're going to structure tonight is in a couple of parts. We'll watch a couple of videos to get an introduction, and then Jason and I will do some pair programming so you can sort of see what it's like. And we anticipate that'll take the first hour or so, and then in the second half, we're going to turn it over to you guys to do some pair programming. We're here to help you out, and then we'll do a report out at the end to see what everybody experienced. That's what we were hoping to get out. What would you guys like to get out of tonight? Sounds good, just that? Okay. Excellent. Oops, gotta reload that. So, just as a brief introduction, I recognize some of you because I'm around PSU a lot. I'm David Whitlock. I teach the Advanced Java Programming course that's offered in the summers. I've been doing that for a long time. And during the day, though, I work for Tripwire. I lead teams there. I'm a Scrum Master. I help make sure that everybody has what they need. And I'm also involved, I'm also a member of the PSEP steering committee. So PSEP is the internship program that the computer science department does with a number of sponsoring companies here in downtown. So that's me and my partner.
My name is Jason Owen, and I recognize some of you because I went through the CAT and I went through PSEP. And then I got hired full-time at a little startup that went kind of flat, and now I'm working at Tripwire, which is awesome. Yeah. So I get to work with David as a software engineer, and we do pair programming on my team all the time. We do TDD all the time, and so I'm excited to teach you guys about those things.
So for me, there's, we're in a very dynamic industry. There's lots of innovation happening around us. But in my experience, in order to really innovate in what you are doing, to create cool new things, to do it quickly, to make sure that you're building software that people want, you need to innovate in how you do things. And two of the techniques that I've really found to help spur innovation and really leverage all of the brain power that's in the room is pair programming and test-driven development. So we're going to watch a couple of videos to give you an introduction. I don't know, I guess we're feeling lazy. Actually, we didn't want to prepare slides or anything like that. And actually, I didn't check the sound before we started, so let's see here.
Something you said for testing, huh?
What?
Something you said for testing.
That's right, yeah, we're... Oh, cool. There we go. Okay. So yeah, I think I've taught in this classroom before. So luckily, the computer remembers everything. So we'll go full screen. Okay, and so we got 10 minutes of there's this.
Hello and welcome to Fun with Pair Programming, an introduction to pair programming for students. If you're a student who is new to pair programming, you've come to the right place. This video will help provide valuable information to make you the best pair programmer you can possibly be in your classes and beyond. Pair programming refers to the practice whereby two programmers work side by side on one computer, collaborating on the same design, algorithm, code, or test. The pair is made up of a driver who actively types at the computer or records a design, and a navigator who watches the work of the driver and identifies problems, asks clarifying questions, and makes suggestions. Switch roles from time to time to share the work evenly and get the most out of your pair programming experience. You'll hear effective pairs constantly chatting as they jointly decide how to tackle the task at hand.
Well, actually, I don't even know where it's saving this stuff. So we create a new patient and it adds a record. Oh,
right.
Probably in save data file. Mm-hmm. So it's going through Looks like a list of records.
So we probably, since we just added the height and weight, I don't know if that's actually getting written.
Yeah, probably not.
Okay.
So
Why do so many thousands of students around the world prefer pair programming? Why don't we ask some to compare old-fashioned solo programming to this new and innovative system?
wait, what was the order?
You would program by yourself, so you'd usually be just by yourself in a computer, maybe in a cube or at a single desk, and it's a very lonely type thing. It can be.
Well, it could be really frustrating. You'd sit there banging your head against the desk and trying to find, the missing bracket, or couldn't figure out why the logic in your program didn't quite work right. And with two people there, it's a lot easier to work those problems out a lot more quickly, so you're not frustrated all the time.
This is nothing new either. Most science labs take advantage of lab partners and small groups. Computer science is no different. You can learn a lot from working with other people. Students find it helps them get better scores on programming projects. Pair programming helps them learn, so they get better grades on exams as well. Mostly, students report that they enjoy getting to know the people in their classes better. This makes it much easier to interact when problems do arise, because you've got a class full of friends instead of strangers. Last, but certainly not least, students are much more likely to figure out solutions if they've got someone to brainstorm with, and this can lead to faster completion times and a better understanding of the subject matter. Students often find the whole experience much more enjoyable and less frustrating. Pair programming will also help you prepare for your career in computer science. In the professional world, people collaborate and pair program all the time, and as an expert, you'll already be ahead of the game. Have you ever spent most of your class time with your hand in the air, getting nowhere on a project while you wait for help from your professor or lab instructor? With pair programming, those days are history, and you'll find yourself having a lot more fun. Who knows? Maybe you'll even look forward to the alarm going off in the morning so you can get to class. Now that you know the basics, let's look at some simple do's and don'ts of pair programming. First, be sure to talk. Not a minute should go by when you're not communicating somehow. Don't say anything that might insult your partner. Even if you're only joking, he or she might take it personally. Don't forget to listen, too. Both the driver and the navigator should be fully engaged in the project. So much so that the driver can pass the keyboard to the navigator at any time, and he or she will be ready for the switch with no questions asked.
Periodically switch positions so you can gain experience in both roles.
Switching helps prevent errors and stimulates conversation, too. Be patient. Be prepared to explain yourself to your partner, and don't get frustrated if they don't understand it first. By explaining your work to your partner, you'll be helping yourself learn as well. Remember the ancient Chinese proverb, "To teach is to learn." And be sure to give the driver a little time to correct his or her own mistakes. After all, no one likes a backseat driver. Respect your partner. The golden rule is key here. Just remember to treat your partner with the same level of respect that you expect from him or her. It doesn't matter if they are from another culture, an introvert, an extrovert, a procrastinator, or the valedictorian. We are all here to accomplish one thing, and everyone has something to offer. Take breaks. You can get more done in 1 hour pair programming than in several hours by yourself. But this can take a toll on your brain. Don't forget to take a break every so often to keep yourself fresh and energetic. When you return, you'll likely see something you overlooked before. Be prepared. Be sure to do any preliminary work ahead of time, and don't be late for appointments with your partner. Their time is valuable, as is yours. Hygiene. Think about it. How would you feel if the person you were going to spend a couple of hours with smelled terrible? Take a shower, brush your teeth, bring some mints. You know the drill. Have fun! Working with someone else can be a lot more fun than working by yourself. You can share a laugh, relieve some tension, and have someone to celebrate with when you get that last test case to pass. Believe me, that's a great feeling.
Now that we've gone through all the things you should do as a pair programmer, let's go through some of the things you should avoid when working with your partner.
Don't be a keyboard hog, or think that just because your partner is a novice and you're more experienced, that they won't bring something to the table. Don't constantly tell other people what to do either. You don't want to be the only person in the class that no one wants to work with because you're too bossy. There is another side to that coin, so don't be intimidated. Some people are afraid that they don't know enough, but chances are your partner feels the same way, and you both know way more than you give yourself credit for. Trust me, it will all be fine. The primary goal of pairing is to work together towards the best possible solution, so don't be afraid to speak up if you disagree with your partner from time to time. Your partner may as well be working alone if you're not willing to speak up. If you're unhappy with your pair programming situation, for any reason, don't hesitate to talk to your professor or teaching aide. That's their job, and they will be happy to help you resolve whatever problem you may have. As you can see, there are many benefits to pair programming, but there are also a few speed bumps. Sometimes you'll find it difficult to find time in your schedules to meet, for example. But students all over the world agree that the benefits outweigh any drawbacks that they can find.
If there's two of you working on it, typically you're spending a lot less time working on it, so this is great for homework. Then also I would say that in general, your solution is going to be better.
So if you're working with somebody and their grade or their deadline matters to you, you're more likely to get your work done at an earlier time. Also with pair programming, you can typically have higher grades on assignments. There's higher quality code as well.
This concludes our journey through the exciting world of pair programming, but there's still much to learn. Take these tips with you into your next pair programming lab and join the growing number of pair programmers across the country, the world, and beyond.
And they got like a minute of credits. Yeah, every time I see that, I forget how cheesy it is. But it's
So good.
yeah. But for me, it's all about that pair programming music they got in the background. It's kind of funky now. Actually, I think that video is sort of spot on in terms of some of the benefits of pair programming, and then just to give an idea of the etiquette and what works and what doesn't work in pairing. One of
the things that I liked is that like maybe a couple minutes in, they were showing the two little people who were talking, and they said the same thing. It's like, I've totally gotten to the point with my pair where we're completing each other's sentences. Like,
I just missed an opportunity to complete your sentence. That would have been so hilarious. Sorry.
Josh and I were like working at one point, and the other two people on our team were asking us a question, and we both turned and we were speaking in unison. It was awesome.
Yeah,
it's a good sign that you're pairing effectively.
And so that's not only good for the two people that are doing it, but having two people that understand the solution, as thoroughly, that brings resiliency to the team. So, like, if someone, gets sick, the other person is familiar enough with the code that they can, pair with someone else. And there's a lot of sharing. Pairing means sharing. Anyway, so that in a nutshell is sort of the container, the box of pair programming. Any immediate questions about that? No.
Have any of you ever done pair programming?
Yeah.
Nice.
Mm-hmm. Yeah. At school or professionally or hobby or?
Internship.
Internship, yeah.
And then your class.
That's true. Yes, yeah, we did that. Yeah, so this is all material from my class. So, okay, cool. So the other video we wanted to watch, it's not quite as long, is about test-driven development. And so in this video, this is Uncle Bob Martin, who is a well-known author, software craftsmanship evangelist. he has a series of videos called Clean Code, and this is an excerpt from one of them. You have to pay for them. They cost a little bit of money. I don't know if there's a student rate or not, but it's for an individual.
It's like $10 each.
Yeah, it's like $10 each. It's the kind of thing that, instead of getting an ugly sweater from your aunt, ask her for to buy you some of these. They're really good and really insightful and kind of wacky at times, but overall really quite valuable. So this is like
and they complement the book too. If any of you have read Clean Code, I highly recommend it. They cover a lot of the same ground, but kind of like side by side rather than too much overlap. But depending on which learning style you have, you might prefer one to the other.
Yeah, I like watching videos, so this works for me. Okay, and so what Uncle Bob's going to do is he's going to demonstrate test-driven development by implementing a little program that simulates a game of bowling and how you score the game of bowling. And you'll see he goes through a pattern of what's called red-green refactor. He gets a test to fail, he gets a test to pass, and then he takes an opportunity to make the code better to refactor it. Lights, please.
Oh, it's time for the red-green refactor cycle. And I am in the red phase. I must write a failing unit test. All right, what test must I write that will force me to write public class game? Well, I'm going to write can create game. Game G equals new game. Oh, heavens. Thank you, IDE. Helpful IDE. That's enough of that. Heavens to Murgatroyd, that doesn't compile. Well, I must make it compile. So now, I'm going to create the class game. Yes, in the current package, there it is, the class game. And if I go back to my test, oh, look, the test passes. It's time for me to go to the green phase. I am now green. And in the green phase, it's time for me to refactor. Is there anything I can refactor here? No. Nothing to refactor. Very good. Then I am done with this test. I am passing. Lovely. Back to the red phase. The next test, well, I know I want to write that roll method. All right. Test can roll. Oh, heavens, I need a game. Game G equals new game. Lovely. G dot roll. What should I roll? Well, let's roll a 0. That doesn't compile. Okay, time for me to focus on making it work. I'm going to create the method roll. Ha! Look at that, roll. And it should take a pins. This is lovely. And I believe that will pass. Because I'm not actually testing anything. Oh, time for me to refactor. I've got a passing test. What's to refactor? Oh, goodness, I've got duplicate code here. Duplicate code. Well, I better take that and refactor that out. I'll create a field named G. I will initialize it in the setup method, which of course I don't have, but this will create. I'll keep it private. Lovely. So now I've got a nice setup method. It's going to create the game. It'll put it in the private field G. Can create game is now empty because, well, it doesn't do anything. And I think I can get rid of that line of code in can roll. And all of this should still pass. It does. I think I can get rid of that empty test now. This is common, by the way. You write a test just to delete it later. Lovely. Next most interesting test case. Back to red. Well, what can I make fail now? Oh, I got to write the score function. But I can't call score until I roll a complete game. Okay, so here we get into some of the technicalities of test-driven development. When you must write real code, you write the simplest real code you can. In this case, I'm going to have to roll a complete game. What is the simplest, most degenerate complete game that I can roll? A gutter game. Let's roll the gutter game. Okay. 4 int I equals 0, I less than how many balls in a gutter game? 20. I plus plus. G dot roll 0. That will roll 20 zeros. That is a gutter game. And now we will assert that the score is 0. Oh heavens, that doesn't compile. I must make it pass. Excellent. I will make this compile. It should return an int. I'll have it return a -1 because I still want to see it fail. It should fail. Yes. And now I will make it pass by returning a 0. This is stupid, but it's also easy. And I have now seen my test both pass and fail. I know my test works. It cost me nothing, but I now know that my test will fail if I don't get a 0. Well, that was nice. What is the next most interesting test case? Or is there any refactoring to do? No. Next most interesting test case.
And fade. And scene. Happy coding. So there's kind of a lot to that. Go ahead, lights back on. So one of the things, a couple of things that I picked up on was, did you notice how much he uses the IDE uses his tools? I don't know about you guys, but when I was in an undergrad, they didn't let you use the tools. They're like, oh, IDE, that's cheating. It's like, no, it's the other way around. That's how you do work. And have the IDE do boilerplate like generating methods and having it tell you what doesn't compile. So instead of like going to the command line and having to recompile everything yourself. And he's able to go really fast because of that and focus on the test that he needs to write, not writing the test. You get that?
There was a conversation in our RC CS chat a while ago talking about how, Java is so bad because it's so verbose. And my answer to that was like, well, you can change languages if you want to get away from that, but maybe the problem is that you're not using an IDE, and Java really benefits from having an IDE.
And that's all about that, refactor phase of test-driven development. So, I guess both that and generating methods. The fact that you say game.roll and it highlights in red and then lets you create the method really easily. It keeps you here again, focused on writing the test and being in your domain instead of having to worry about the language. Earlier today I was refactoring some code, and it was so nice to have like a statically typed language where it's like, oh, I changed it in one place. Oh, that's right. There were 2 other places. The compiler caught it, and I was able to figure it out pretty quickly. What else about what he was doing? I want to call out the IDE. Did you get what he was saying at the end about making it fail before making it pass? That was something that I've kind of had to learn the hard way. Because originally when I would write unit tests, write tests, I just make it pass. I was like, great, it's passed, and I'd move on. Then oftentimes you find that it's passing for the wrong reason. So always write a test that fails, even if you're saying stupid, like, instead of returning 0, return -1, just to see that it will fail and that you don't have a false positive for that.
And not compiling counts as failing.
Yep.
So he did a couple of times with like, all right, we're just going to make sure that we can fail the test because the test doesn't compile because I'm using a thing I haven't written yet. That counts.
Yep. So any other observations or questions that you have about the Uncle Bob and the hat and everything like that? The hat exists, right? You sent me a link to that?
Yeah, so the guy who made the hat is not Uncle Bob, but Uncle Bob wore it, and he got a lot more attention for it than he intended. He just wanted it as a prop for a video like that. And so he put it up on the web. The plans are Creative Commons, like by SA or something. And so basically he just got 3 different colored baseball caps, cut 2 of them up, and glued them onto the third. So in case you want to make your own red-green refactor hat.
Cool. And also, if you want to learn more about unit testing, and I guess there's another thing I wanted to point out. So he uses a framework called JUnit, which is a series of APIs and annotations for authoring and expressing unit tests in Java, which gosh, it's been around for a long, long time. I'm trying to think.
And there's
like 15.
There's
plus
similar
years, yeah.
libraries for
Yeah.
most languages. So there's I think they call it XUnit for like the general pattern, but they have it for, I've used it for C# and something else. So there's all kinds of, this pattern exists in many languages.
Yep. Yeah, and so what we're going to be seeing here tonight is Java, because that's what I know. And but no matter what language you're working in, there are frameworks out there to let you write unit testing because it's very useful. I guess we should probably talk about what unit testing is as opposed to other testing. So unit testing is meant to test the units, the small things in your program, like your classes and your methods, as opposed to like integration tests or like bigger system tests where it's like you spin up your entire web server and the database backend and everything like that. Those are really expensive tests, and they're not only to author but also to get working and keep working and stuff. And so unit tests, I think, work especially well with test-driven development, where you're sort of, and that's another thing I guess that I want to call out. You notice that he went into that and didn't really know what he was going to write, didn't really know what the classes were going to look like, all the methods and everything like that, and that's okay. And that's part of what TDD gives you, is a sort of exploratory approach to writing your code. So instead of going through and figuring out exactly what your code's going to look like and coming up with UML diagrams and big big design up front, you let it emerge. And the cool thing about unit tests is that as you add more stuff to your code, you can go back and rerun your unit tests and make sure that all of the assumptions that you made about your code 5-10 minutes ago or even last week are still valid.
Does it matter whether you write the tests or the code first or vice versa? Is there a difference?
I think so.
I mean, for it to be TDD, kind of by definition, the tests have to come first. So TDD is test-driven development, and it's easy to write code that is difficult to test if you write the code first, I found. Right.
And so sometimes you can sort of back yourself into a corner. We've got all the implementation. It's like, oh, well, how do I send it the right input? And so then as a result, you end up having less code coverage because it's harder to test it after the fact. Also, I found that TDD really helps you focus in on the problem that you're solving and understanding that. I mean, I can think of lots of times in my career where I've implemented something and I'm so proud of it, and I realize it's like, oh, this doesn't really do what it needs to do, or it's hard to change it to do what you need to do without breaking a whole bunch of things. And so we have this like automated suite of tests that tested at a low isolated level. You can get a lot more confidence in your code.
Yeah. So having test coverage of your code makes it really easy to refactor, because if you broke it on the way. It's kind of like having, so in another book they call it like developing with a net. So, if you're trying to do all this stuff.
Who's a net? Sorry.
If you're trying to do all this stuff and you don't have that safety net beneath you, you could be introducing bugs and not realize it. And you think that this really simple refactoring is going to, allow you to make the change that you need to make, but secretly you're introducing this bug, and it might take days or weeks or months to find it. And the longer it takes to find it, the more expensive it is to fix it. So you have to get that all back up in your head and find the place that's causing the problem. Whereas when your unit tests run within a second, and you run your unit tests within a couple of seconds of you writing the code, it's practically free to fix it. Like if it doesn't pass, all right, keep going. As opposed to like, oh, I kind of remember that from last year. Let me see, there was that bug and this bug, and what all was wrong?
Yeah. Trying to gain that context. Okay. Well, so let's do some test-driven development.
Yeah.
we identified a couple of very small problems that we're going to apply pair programming and test-driven development to. They're both called code katas. So kata is a little practice from martial arts. The whole idea is that it's small, so it's not like a big thing. There's a very isolated problem, and it's meant to give you practice doing a particular particular move. In this case, it's test-driven development. So let's introduce the what the kata is going to be, and then we'll talk about some of the code behind it. Have you guys heard of Fizzbuzz before? Yeah, a couple of people. Well, what I've heard is that this is often like a little programming problem that people give on job interviews. And it's true. Yeah, these are the kind of little things that we'd expect someone that we're looking to hire to be able to do and to do quickly and to do well. And it's a pretty simple problem, right? So yeah, I don't need to know this whole imagine the scene stuff. But basically, there are numbers, and what the program's supposed to do is print out the number unless it's divisible by 5, and then you say fizz. I'm sorry, wait, sorry, it was 3. Right, divisible by 3, it should print out fizz. Divisible by 5, it should be divisible by buzz. And then, what is it like? Oh, and then down here, if it's both divisible by 3 and 5, print Fizzbuzz. Yep. Not very practical, but it's good for demonstrating test-driven development, and it's also the kind of thing that you should be able to figure out in your head pretty quickly and implement pretty quickly also. Anything else on that? Does that make sense? So remember the rules, and then what we're going to do is we'll develop an application that implements those rules. So what we did to prepare was we put together a repository up on GitHub. And so for those of you playing along at home, go to github.com/David Whitlock/pairing and TDD Nov 2015. And you can check out the repository. You can clone it locally. And then inside this Fizzbuzz kata, let's see here. Inside the Fizzbuzz kata directory, we've got some source code to get us started. And basically what it's the skeleton of an application. I'll bring it up here in my, we'll minimize that one. Fizzbuzz kata. It's an very simple little project. It's got 2 classes. It's got a Fizzbuzz test that tests a Fizzbuzz class. And it's built using the Gradle build tool. And so then if you want to build it from the command line, you just say Gradle W for the Gradle wrapper and then build, right? Yeah. And so Gradle will go out, the first time you guys run it, it'll download a whole bunch of stuff like third-party libraries, the whole Gradle system and everything. And then it compiles your source code, and then it'll run your tests. And if things fail, so let's make it fail so we can see what it looks like, equal to 0. Oh, I put local changes. That's not right. Here you go. Cool. It tells you what failed and why. I probably need to pull down that into the README and stuff like that, but we'll do that later. Okay.
Well, we should do it now.
Want to do it now? Okay.
Cool.
Sure. Oops.
Or you can do it in the IDE.
Cool. Okay, now I've synchronized everything. Let's get rid of these guys in here. Okay. Okay, well, so let's implement this Fizzbuzz. How about you drive first, and I'll be the navigator?
All right.
Okay.
So let's see. Can we vertically?
That's a good idea.
What's that? Okay. So the class and the tests, you do not have tab to click on.
I do not have tab to click on. Yeah, I know. Well, and this is another thing, right? So now, yeah, and actually, do you use the Mac much? Do you have like Mac at home or? You're a
My
Linux
last
guy.
job.
What?
My last job, I had a Mac.
Okay.
So, okay. So right now it's just echoing this out, and we want it to echo the number for some of them. So so we have that for 1. What does that say? Echo 1 is 1. Okay. And it's doing weird things that I'm not used to. Why is it doing that?
Because you're hitting the right arrow?
Yeah, but there's no text there, right?
Yeah.
All right.
It's freeform, man.
Yeah. All right, so 2 is 2 is probably boring, so should we just do, well, 2 is 2 is not boring yet. All right, so this is going to pass because...
Right, yeah, it is. Let's not make that pass. And actually, echo doesn't seem like the right name for that either. Where is it?
So what are we calling this? Speak? I don't know.
That's a good point, yeah. So like, what are we modeling here? Yeah, we're modeling, I guess, a student in the class speaking.
Do you want to call it that?
Let's call it that, yeah.
Vector name. Oh. Alright, so
Cool.
update everything there. So, and this can be
First student speaks 1. I don't know, is that too verbose? Or says 1,
says
yeah.
1.
Yeah. Says 1.
Oh. Second student. So this is boring. Let's not do that. Let's do third student says fizz.
Okay.
Alright. So we're gonna say fizz and 3, and that's not going to compile because
Put on the red hat.
Yep.
Yeah.
Oh no, we finished the red hat. Put on the green hat.
That's true.
So this should be a string, right?
Yep. Mm-hmm.
And so now we can say, what can we say? Well, so now this is failing too. So this needs to be quotes. But this is what? Number?
Integer dot toString.
Integer dot toString.
And give it a, okay.
And should we, vector, what is the shortcut? Shift F6.
Yeah, F6.
Student number?
Yeah.
Alright. And that.
I don't know if it's going to run all of them or not. Oh. Yeah, we changed the signature. So just right-click in the test and then say run. Maybe the second one. Yeah, I don't know, Gradle something or other. I think it's just going to run the first one. Okay.
So do you want to do it from Gradle?
Oh yeah, we can do it from Gradle. I've run the command line too. This is slow.
Gradle is 5 seconds.
You should try doing it with Maven. You want to see some slow.
Alright,
Oh,
so
something failed.
tests.
Okay.
Yeah, great, as we expect.
So the second one failed? The third student says fizz?
Yeah. One
Cool.
failed. So, so if student number %3.
Yep. Equals 0.
Oh, thank you. 0. Return fizz.
Yeah. Yeah, let's give that a try.
We could probably just test, that might be faster. Alright, so that passed.
Cool.
So,
Can I have a turn?
Yeah.
Oh, you know what we should do though? We should commit it.
Yeah.
So okay. So yeah, here's another thing. So we have the code is in version control. Apparently thanks. And so we've made some changes, and so we've got it back to a passing state. And I like to do lots of little commits, especially when you get something stable, because then if you destabilize and everything's messed up, you just need to revert back to the last check-in, and you don't have to worry about trying to undo or go back in your local history.
Let's see, there we go. Commit dash fizzing.
Haha. Fizzizzle? Okay. Excellent. Okay. So my turn.
Yep.
Okay. So, oh, and we need to synchronize this to get all those change bars away. Let's see here. Oops. Synchronize. Okay. So let's see here. What's next? It's interesting. So you said that a test for 2 was boring. Well, why is it boring?
Because we knew it was going to pass.
So we knew it was going to pass. That's true. And so probably what I should have done is like the initial echo should have just returned 0.
Or yeah.
Yeah, it should have returned 1, and then when we wrote that second test, it would pass. So, and that's a good point. I mean, so if you know that the test is going to pass, should you even write it?
Depends on how interesting it is, probably.
Yeah.
If it's something that you expect might stop passing soon. But I think that one's pretty stable, and I think it's not enough different from the 1 case to catch risk that is worth that amount of cost.
Okay, I can buy that. Okay, so let's see. What's the next test to write?
5 probably.
Okay. So 5th student says buzz. So student of 5 says buzz. Okay. Okay, so I'm going to run it from the IDE. Okay. The whole test, oops. Okay, so it's saying down here. Actually, you guys see that okay? Yeah, I guess it looks okay up there. Kind of stretched out, but okay. So was it telling me? Okay, expected buzz, but was 5. Oh, you know what's something that I didn't point out here. We're in addition to using JUnit, which gives you things like this @test annotation. We're using a library called Hamcrest, which is actually an anagram for matchers. Like one of my students pointed that out. It's like, oh wow, yeah, that's because Hamcrest makes no sense. Anyway, and this gives you methods like this assert that and the equal to, which give you assertion statements that are more readable. So JUnit will have the JUnit syntax, which you saw Uncle Bob use, has this assert true syntax that takes. Oh, I guess I got it imported. Oops. That takes. Right, it's overloaded to have different parameters, but you can just give it like a Boolean condition or assert that the way to write this in JUnit syntax would be like, let's see here, fizz is the expected value, and then
I think that's the message that you print out.
Well, when I get the second parameter, I think it'll figure it out. Fizzbuzz.speak of 3.
I think it needs to be. I think it's a condition. If you do the
No,
first one
interesting.
is the message.
Oh, assert true. Assert equals is what I wanted. That's why.
Okay.
Yeah. Thank you. And yeah, there it is. Like that. And this works fine. I just find that the assert that is way easier to read.
And the output down at the bottom is nicer.
Yeah, much nicer. So anyway, Hamcrest has some sort of advanced things that may take you a while to really grok, but I found that it's worth it. Anyway, because yes, you do get much better error reporting. Okay, so it's red. Let's make it green. So here, let's see here. If it's that, return fizz. Otherwise, if student number mod 5 equals 0, return buzz. And we'll tab complete that. Return buzz. I'll run them all again. Yay! And everything passed.
Do you want to commit?
I'm going to commit, and I commit from the IDE. Although, that's how come it's not? Oh wait, here we go. Local changes. There you go. Cool. Let's see here. Added Implemented. Oops. Implemented the buzz logic. Commit. Yay. Okay, back to you. I'm spent.
All right, so I think probably the next most interesting is 15.
Do you want to do another multiple of 3 or another multiple
Sure.
of 5?
Does this JUnit have unrolling? Can we
I don't
have
know.
it do a whole bunch of multiples of?
I think I
JUnit
used the
5?
latest JUnit. I haven't used unrolling in JUnit
I've
before.
used it in Spock. I haven't used it in
Oh.
so.
I don't know.
All right.
I don't know how to do it on.
Yeah, I don't know either. All right. So you want to say like what 9?
Sure.
Says Fizz. Right. So that Fizzbuzz dot speak of 9 equal to Fizz.
So we expect this to pass, right?
Mhm.
Yeah, it does.
Yep.
Okay. So not so exciting. Yeah, so I mean, it's like, I guess the logic is so simple there that we're probably okay with it.
Yeah.
Okay.
Alright, so are you ready for 15 or you want to do something else in between?
I can't think of anything else that won't already pass. What do you, the audience at home, think? Okay. Breaking the third wall here. Fourth wall?
Are you exclusively looking for tests that will pass? Because you could try to write a test that, say, puts in negative numbers.
Oh, boundary conditions. That's a good idea.
Yeah?
What do we do?
What do we do? What does the spec say?
You could write a test that expects a condition or an exception once an
Yeah.
invalid number.
Yeah.
Because that could be the test passing
Sure.
is the code throwing an exception.
Right, yeah.
If a number throws.
Yeah.
And how do you do that? Is there a
You say no. It's
No.
it's a parameter to the annotation. So you say expected equals. I think it'll and then you give it the class. So we're gonna have a throw.
runtime?
Illegal argument exception.
Yeah,
Do you
okay.
want to have like a? We could have our own exception class.
We could.
That would be
Enterprise?
enterprisey. Illegal. You know, it's
Sure.
after work hours.
Not a student number.
Exception that class. Yeah.
All right, so
do
that's
it.
failing. So let's oops.
I think it's
Command?
Alt.
There you go. So create class.
Yeah.
Sure.
Yeah.
Yep. Yes. And we should extend legal argument.
Yeah. Good idea.
Do we need to put anything
Well,
in?
maybe we do, maybe we
Yeah.
don't. Let's see what the implementation looks like.
Well, yeah, so for starters, it compiles, but of course it doesn't pass.
Right, because no exception was thrown.
And of course we're not even doing anything yet, so let's do fizzbuzz.speak, -1.
Yeah.
And that still doesn't pass. So should we just numbers less than 1?
That's,
right?
Yeah, less than 1. Yeah, so I guess we'd have 1 on 0 also. That makes sense, I guess. Yeah. Oh, brace, please. You're gonna have it all in one line.
Sure.
I hope you're using space and not instead of tabs. Otherwise, I can't pair with you if you're one of those tabs people.
I mean, can we talk about this trailing white space over here?
Yeah, I don't know. Yeah, I blame the idea.
All right. So, how's that? Okay.
Nice.
And so the other side of that spec is more than 100, right?
Oh, it's true. Yeah, yeah.
So let's do. Oops.
So what he's doing is he's duplicating the code, right? Open
Yeah.
Apple D. That's Command D.
Large number of throws.
Yeah, or more than 100 throws, but yeah. Darth, she throws.
fails. So, what, or?
Yeah.
Student number, greater than 100. Ta-da.
Yay! Yeah, good call. Okay,
Make you
let's take it home.
Resync.
That's all right. I like the command line. I'm a big fan. I can't find the name. There we go. Okay, so we got one more. That's 15.
I think so.
Yeah, I think so too. So let's quick copy and paste that. 15th. Student says Fizzbuzz. And run it. Control Shift F10. Okay, but was Fizz? That makes sense. So let's see here.
So it probably has to go first.
Probably do, yeah. Yes, it definitely has to go first. Okay. So if student.number divisible by 3. And, or do we say by 15? Is that the same thing?
I think it's the same thing. This might be more readable.
I think it's more readable. And certainly it implements the spec more succinctly, because like what the requirement was. Don't forget that else.
Why is it upset?
Oh, equals 0. Okay. And then return Fizzbuzz. I don't know, should we introduce constants for these?
Not yet.
Oh, yeah.
There's not enough duplication.
Well, it's there in the test, and it's there in the... That's a good question.
true.
Yeah, but I don't know, maybe it makes it more testable to have that in a con... Well, let's get it
Yeah.
green first, and then we'll refactor.
Yeah.
So we need to think about this yet. It's not even passing. My goodness.
Okay.
Heavens to Murgatroyd. So yeah, it's like... I think we're done.
I think
And
too.
so, like, can we improve this by introducing a constant here? Perhaps? I don't know. If we wanted to localize it, now I think we're just getting ridiculous. What's Fizzbuzz in French?
Enterprise Fizzbuzz.
Enterprise Fizzbuzz,
Have
yeah.
you seen that?
Oh, is there like
Oh.
yeah.
We should look at that later.
Okay, excellent. Okay, we're passing. I don't see any opportunities for refactoring here. There's not a lot of. I suppose we could do something like refactor this out into a method, but I think But I think it's more clear this way.
Yeah. If we wanted to keep going, we could go research if there's unrolling for JUnit and figure out how to sort of parameterize these and just have like a table of like, all right, so 3 fizz, 5 buzz, 9
Oh,
fizz.
yeah. That'd be cool. But for another time.
Yeah.
Because, our time box is up and I'm an old man. I'm getting sleepy.
Okay.
So, version control. Okay, excellent. Commit changes. And so then this is implemented the Fizzbuzz. Oops. Logic. Else commit that. And we're done. Now, how did we know we were done?
All of our tests pass, and we can't think of any more to add.
Yep. Which is the cool thing about DDD, right? You know when you're done. When you can't think of any more tests to add that aren't degenerative, that aren't going to pass right off the bat, you're done. And so now we can walk away.
This was super useful for me in my compilers class. When I had the spec up front, I just learned about TDD. I decided that that was more interesting than actually doing the assignment, so I just wrote a whole bunch of tests for all of the things I could think of, which turned out to be really rewarding because as I was implementing piece by piece the compiler parts, I could see the sort of percent passing go up, and when it was 100%, I knew I was done because I couldn't think of anything else, any other tests to write.
Now there's a piece of Git magic that I want you to show me how to do, which is the squash, the whole. Okay, so we were making little check-ins along the way, and these little check-ins were really good for showing our progress, for giving us a place that we can roll back to if things got gnarly and all messed up. But in terms of like what I want to share to the world, I don't need like 27 commits up there in my GitHub repository, especially when you've just like sort of one unit of work. And so there's this, what was it? Rebase.
Yep.
That is an important part of the workflow, but it's something that I have like this like mental block where it's like I don't understand it. So maybe you could show it to me, Jason, and maybe I'll do better. About it.
How many of you know Git? At least a little bit. How many of you have ever done a rebase? A few of you. Decent number. Okay. So
last summer I would have made a joke like it's all about rebase, but I probably did make that joke last summer.
What's the no part? You got to finish that thought.
I don't know. No conflict.
No revert.
No revert. Yeah.
Okay. So. What am I looking for? So we have a bunch of commits here. They are, so probably we only want, you want to just squash down to the bio, right?
Yeah, so like that was the commit that you made this afternoon.
Yep.
And so, okay, so you go and you get the...
so if you're not super familiar with this, it's useful to a rebase. And so that way, if everything goes sideways, you can go back to master and you don't lose anything. And it's much easier to do that than to do the ref log and the reset and what other deeper magic.
I tried to do that, and it's like, I blew everything up.
And I'll show you that, but we don't need to. So this is the commit that we want to base it off of. So this is saying that everything after this commit, so everything above, is fair game for this rebase. Everything below it, everything older than it, is not. Yeah.
After and including, or after excluding?
Let's look. It looks like after not including.
Okay.
So, I did that command and it brought up the editor, brought up Vim and says, all right, so we got four commits right now. If we were to just pick all of them, we would be left exactly where we started. We do not want to pick all of them. We want to have one commit that includes all of them, right?
Mm-hmm.
All right, so we can change that to squash. Oops. Change that to squash. Change that to squash. So once I write save and quit, then Git will start working. And so we are creating a new commit that has the contents of the 4 commits that we squashed together. And so it says this is a combination of 4 commits. Here's the first commit message, second one, third one, fourth one. I think all we really need to say is implemented Fizzbuzz.
Okay.
Right? Do you want to add anything more than that?
A good time with that by all. No. We're all good there.
All right. So now if we get show head.
Detached head. So medieval. All right.
Yep. Oh, jeez. Why does it do that?
I don't know.
Okay. Because your terminal, you should get a nicer terminal. So here's our commit. Here's the old, here's the new, and so this is on the fizzbuzz.java.
And this is a git diff you just did?
Yes. No, this is git show head. So this is showing the latest commit. So here's the new git hash.
Gotcha.
You'll notice that the date was actually from the earliest commit.
So the first change, okay.
And there is a way to show a fuller version that we'll see on GitHub, maybe. Actually, this is being committed as you, so it might not show it. If I had done it, it would say what you authored, I committed.
Gotcha.
And so it'll have like his icon and then mine little. So this looks pretty good to me. And so now, I wish I had my, here, get help log. I want, sorry, there's a way to show, do any of you know how to get the pretty tree log? The one line? Yeah.
And then dash out one line.
Like that?
Yeah, dash out decorate, dash all.
Yeah.
Let's start
Usually
with
don't
that.
have that much problem like that.
Yeah, okay. So, oh yes, dash dash all, you're right. Yeah, okay. So what we see here is this is the commit we just made. Here are the 4 on the other branch, and decorate would probably show what branch they're all on. But this looks good to me, so we can go git checkout master, and we can git reset hard to the commit we just made. And now if we do that again, the other branch is gone. It still exists though. If we needed to get it back, we can get reflog. But again with the pager. So this is the latest thing that we just did. It is the reset moving to this. Previously we were on this hash, so if we wanted to go back to the way it was before the reset, we could git reset hard this, and that would put it back the way it was. It also shows the Rebase interim commits that it was doing. So we started here and finished there, and in between it did some stuff. So that's Rebase and reflog. Is that what you were hoping for?
I was hoping that I'd understand it. Okay, no, I think I get what it's doing.
Okay.
There's a lot of commands. Okay, so then what's on my master right now? Are we ready to push it?
Yep, we're ready to push. All right.
Okay, let's go take a look. Okay, awesome. Yeah, so let's reload this dude, and we should see. Yeah.
To here.
Here you are, 4 minutes ago. Nice.
There you go.
There are changes.
Yep.
Okay. Awesome. So that's okay. So we did some pairing, and we learned a little bit about Git, and we had fun too. And so now it's your turn. So we've identified another kata that we think would be good for you guys to try. This is actually not that different from the bowling one. Oops. Oh, yeah.
I should have fixed it when I ran into it.
Yeah, we can fix it right now. So here, this is a kata that implements a simple tennis game, or the scoring algorithm for a tennis game. Thinking about Wii Tennis or tennis. And so then hopefully you're all familiar with how tennis is scored. There's basically 3 points in a game, so a player can have 0, 15, 30, or 40. And then if you have 40 and you win the serve, then you win the game. However, unless both players have 40 and then you're in deuce, and then let's see here, what is it? The winner of a ball will have the advantage. So if you're serving, you have advantage. And if the player with the advantage wins the ball, then he wins the game, et cetera, et
Wait,
cetera.
so if you start at 0-0,
Yeah.
and we're playing against each other, and I serve, and you hit it, and I miss, then what happens?
I win, and so it's 0, 15. So right?
So it's immediately 15 points?
Yeah, it's like increment. Tennis is the one with the brackets. Okay. Okay. So maybe not everybody knows. That's fine. That's fine. Yeah. Yes. So like there. Yeah. And yeah. I mean, the numbers actually make no sense. It's actually kind of like a little finite state machine. Imagine that. Yeah. So it's like you go from 0 to 15 to 30 to 40. Okay. Next time we'll do cricket. I don't know anything about cricket. Right. And then there's this whole end game where like if you both have 40, then it's like you get an advantage, and if you have an advantage, then you win. So to get everybody started, also there in the same repository, we have another project in the tennis score kata, the same kind of thing. And so then, let's see here, I think I've got it here in this other window. And you start out with like exactly the same the same skeleton, although I think here the logic is a little bit different. Here I think it kind of requires some object-oriented programming and things like that to be a little bit more interesting. So let's we'll stop talking, and we'll start helping you guys pair up. And so let's see here. I mean, you're not terribly mobile, so if anyone wants to come up here and pair with Jason, you're happy to do so. And I'll wander around the room. Any questions before we get started? Yeah, okay. Cool. I'll stop the video.